So I'm going to introduce my test bench of my problem. My problem is to simulate a priority arbiter. An arbiter is a machine to decide which subsequence can be accessible to the shared resource. And you can see the problem description in my report. So let's see the test bench and the simulation result. Uh, so in the simulation result, you can see first I set break 0 to 1 here, and then as the next rising edge of the clock, the GNT 0, which means the subsequent, sub, sorry, which means subsystem 0 is using the shared memory. This value rise to 1 here, and one reach 0 keeping to be 1, GNT 0 keeps to be 1. And one reach 0 becomes 0 here, and I have already rise reach 1 rise here, and then at the next rising edge of the clock, the GNT 1 rise to 1. So similarly, at this point, when reach 1 back to 0 and reach 2 rises to 1, and then at this point, GNT2 becomes 1. Then I set reset to 1 while keeping reach 2 to 1. I have set reset as the greatest priority, so the machine should reset to ideal. So you can see when reset rises to 1 here, then at the next rising edge of clock, GNT1 becomes 0. Actually, all GNTX should become 0 here, back to the origin state. And when reset becomes 0, the machine works again. GNT2 rises to 1 here, and similarly I test reach 3 and then GNT3. Then at the next point I test the priority of reach X. I have already raised the reach 0 and reach 1. For the requirement of the problem, the priority of reach 0 is larger than reach 1, reach 1 is larger than reach 2, reach 2 is larger than reach 3. So at this point, when reach 1 and reach 0 are all 1, the machine should rise GNT 0 instead of GNT 1, and we can see it really does. At 1, reach 0 becomes 0, and reach 1 rises again. And I think the most interesting cases is the reset part and the priority part. That means I have finished the requirement of the problem properly.